Okay, welcome everybody. Thanks for coming. This is the week 2 webinar of the statistics class. And just to let you know, unlike last week, we only have one webinar a week other than last week, because last week we had the orientation too. So this is the webinar for the week. And the plan today is I'll take any questions as always, and that's in every webinar. Then we're going to get into chapter 3, which is actually not that long a chapter, but a lot of people have difficulty with some of the questions because it involves a little bit of math thinking. We'll talk about what is probability. So that we'll define probability. And then I have a question. If I buy a lottery ticket, what is my probability of my ticket winning? Okay. I don't know if you ever thought about that, but it's a good thing to check, and we can actually calculate those kind of things now because this is all about probability. And then this sounds like really easy, like you all know what this word means, and, but I'm going to pretty much focus on how do you use that word when it comes to probability. So we'll get into this and idea. And then the next important word is or. It's a lot of important words. So there's
Can you
and,
speak
there's,
in?
hmm?
No.
I think I'll mute you. So there's, yeah. So by the way, if you have questions, you want to talk, you can, but I'll mute you if there's background talking or something. So then there is the word or, and how do you find probability of something or something else happening? And then we'll get into the word given. So if you're given this is happening, what's the probability this other thing is happening? And all these will be probability kind of formulas and stuff. Then we'll talk about what does it mean to be mutually exclusive and how do we determine if it is. And then we'll talk about how do we find out if events are independent or not. And all this is probability stuff. And then finally, we will talk about project one. I know it's not due for a little while, but this is the kind of thing where you don't want to wait till the end because it's a project that does take a lot of time, and sometimes the hurdles can get through and issues and all that. So project one is an important thing. At this point, hopefully you all have partners because that was supposed to happen last week. And then now you can actually hear about it because we'll have talked about what you need to know for it, and then you'll get to do it. And that project is, again, it's a statistics project about, collecting data and looking at it. So that is the main plan. I do want to let you know, give you a heads up, and hopefully it'll change really soon, but LibreText is down, which LibreText is where the book resides. It's also where the regular calculator resides, not the project, but the regular calculator resides. So if you're having trouble getting in, I am too. And so have other people I've talked to. So hopefully it'll come back up soon. It's actually hosted by UC Davis, so maybe something's happening there. I have no idea, but it was kind of a bummer. So sorry about that. And it's not just this class. I tried it, and I even tried it logging in as a humanities class, and that didn't work. Looking for a textbook in humanities. So apologize for that. Hopefully it'll come up really soon. So that is the plan for today. Are there any questions? A great time to ask. Any questions? Okay, if there's no questions, then we can go and we can look at probability. So, I put it in here. Yeah, there it is. Okay, so for example, there's lots of examples I've got, and I try to pick things that you might be familiar with, and you might know what these guys are. Okay, so these are cards. A question, are we going to go over what was going to be in the week 2 exam? Yeah, I'll mention that towards the end. We'll definitely talk about that, what to expect. Um, so yeah, so I'll mention the week 2 exam towards the end. So these are cards, and if I randomly pick a card, what is the probability that this card is heads? What do you think? how do we find out the probability that this card is ahead? This one that I just picked. And the key on this, if you don't quite know what probability is, what I'm going to do, first thing I'm going to put in some math. And one of the things about probability, which is really important, is when you find a probability and you calculate it, it's going to be a fraction. Whether you like it or not, it's a fraction. So it's going to be a fraction. And there's a numerator and a denominator. The numerator will be how many ways can make that happen. So if we want the probability that it's heads, how many heads are there in a deck of cards, in a standard deck of cards? Anyone know? Oh, sorry, not heads. Sorry about that. Spades. I want to do spades first, so we'll do the heads next. Sorry, I apologize for that. There are heads in a standard deck of cards. I meant spades. So what's the probability that this card is a spade? How many spades are there in a standard deck of cards? Yeah, there's 13 spades. Okay, there's the ace, king, queen, jack, 10, 9, 8, 7, 6, 5, 4, 3, 2. Okay, so there are 13 spades. And how many cards are there in a deck? So the numerator is all the ways that make you win or make it happen. And the denominator is all the different ways that things that can happen. Yeah, there's 52 cards in a deck. So it's 13 over 52. Okay. What if I take a coin? There's a quarter, by the way. And I flip the coin. What's the probability that it's heads? Yeah, it's 1/2 because there's one head, one side that's heads. That's how many ways of getting ahead. And there are two sides on this coin. So it's 1/2. Isn't that easy? Okay. So the good news is things like that are easy. The bad news is it gets harder and harder and harder. It definitely can get harder. But I like to start out pretty easy. Any questions on kind of how probability works for kind of basic stuff? So here's the formal definition, and that is the probability of an event A occurring is the number of ways A can occur divided by the total number of things that can occur. So we had spades. There were 13 ways a spade could happen because there were 13 spades. And there were 52 things that could occur. There were 52 cards in the deck. So the probability of A is the number in A, the number of ways A can happen, divided by the number in the entire set. Any questions at all on kind of this basic probability? Okay, now let's get into something a little more complicated. Let's say now I pick 2 cards. So I just picked 2 cards out of this deck. And the question is, what's the probability that both will be kings? That's going to be a bit harder than what we just did because now we have 2 cards. Any questions on the question? And you might think it's 2 out of 52, but that's not going to work. It's a lot more complicated than that. So we're going to use is we're going to say, well, let's start with the first card. Probably the first card is a king. What is that? How do we get the probability the first card is a king? So it's going to be a fraction. How many kings are there in the deck? There are 4. And there are 52 cards in the deck. So the probability of the first card being a king, which I'll just call K1 for king 1. Okay, we want the probability they're both kings. So what we do is we say, well, all right, we want the first to be king. And if this first is a king, then we need to find out the probability the next one is a king. And the way you write this is I write P parenthesis K2 for the second being a king. And then this little line segment here, you read that as given. So probability of K2 given K1. So given that the first is a king, what's the probability the second is a king? So now let's see if you can think of that. If you know the first was a king. So for example, that was the first card. What's the probability the second card is a king? Any thoughts? Let's see, all jumping in. The first thing you do is you think of this as a fraction. What's the numerator? How many ways are there to get that second one to be a king? Yeah, the numerator is 3 because we know that this card was first, so the second card cannot be the king of diamonds. So there are only 3 kings left. Does that make sense? And the denominator is how many cards this second card could be. Well, guess what? This second card cannot be the king of diamonds. So there's only 51 cards that are left that it can be. So it's 3 over 51. Any questions on that? Any questions so far? Okay, then there's a really important formula. And again, we are going to have some equations in this class. And the good news, it's an online class. You're welcome to, use notes that you can write this down so you have it when you're doing the test, for example, that's this week. That the probability of A and B is equal to the probability of A times the probability of B given A. And that is always true. So the probability of A and B, we want to find that are both kings. So that means the probability the first is a king and the second is a king. So that's the probability of K1 and K2. And that's equal to the probability of K1 times the probability of K2 given K1. So we can actually use that. And I could say that's equal to 4 out of 52 because that was the probability of K1. And then the probability of K2 times K1 was 3 over 51. And then I multiplied those two together. And you can drop that in a calculator. There's no reason to do it by hand. And you get 0.004524886878 to a lot of decimals. Any questions on how that works? Any questions? So these are really important examples. Okay. Remember, and means they both occur. And this little line segment is a given. That means that we know the right-hand side occurs. Now, after knowing that, what's the probability the left-hand side occurs? Any questions at all on this idea? Any questions? Okay, now comes a fun one. Okay, let's suppose now you pick 5 cards at random out of a deck. What's the probability of getting a royal flush? Okay, that's going to be a lot harder. First thing, do y'all know what a royal flush is? Because I don't require that you know everything about, any kind of card games. What is a royal flush? Anyone know? In a game, there's a game of poker. What's a royal flush? Tried to pick the most easy one to talk about. Any thoughts? So what does it mean if I got a royal flush? What does that mean that I have in terms of my cards? So it means 10 jack queen king ace, but it also means not only is it 10 jack queen king ace, but they're all the same suit. Does that make sense? So a 10 of hearts, jack of diamonds, queen of spades, king of hearts, and an ace of clubs, that wouldn't be a royal flush because they're different suits. But a 10 of diamonds, jack of diamonds, queen of diamonds, king of diamonds, and ace of diamonds, that's a royal flush. Is that clear? Okay, so what we want to do is we need to find out what is that probability. So what we do is we say, how many royal flushes are there? Well, you know you have to have an ace, king, queen, jack, 10, but it could be hearts, diamonds, clubs, or spades. And all of those will work as long as they're all the same. So that's four on the top. So I put four, and I'll talk about the bottom in a bit because that's hard. Any questions on that piece? Okay, now comes the part that it may or may not work exactly because we have to use the calculator and it may not open. We'll see. Aha! Yay! Got so lucky. It looks like it's back up. So it looks like the LibreText site's back up, so I can do this. So I'm gonna go to LibreText site. What do you think we're gonna use? And the hint is, and I mentioned this in the I think in the orientation, is that I put these in the order at which we do things. So what calculator number do you think we need to use? Any thoughts? Which calculator should I click on? Number nine, not number nine, because we haven't had expected value. We haven't had binomial probability. Can't be normal probability. Okay. It's right after the one we've already had. Yeah, number six, because we talked about z-score and we haven't talked about combinations and permutations. Okay, does that make sense? It's not number three because we've already talked about z-score. Okay, so now what it asks for is N and R. N is a total number that you're picking from. So in this case, we're picking from 52 cards, and we are picking 5 cards. And that's R. Any questions on that? Okay, so now just a note, if order matters, it's PNR. If order doesn't matter, it's CNR. Now, if you know anything about poker, does it matter what order the cards are in? So if you have a 10, queen, jack, ace, king, all of spades, is that still a royal flush? Yeah, that's still a royal flush. So order doesn't matter. If order doesn't matter, it's a CNR. C stands for combinations, P stands for permutations. So I'm going to click CNR and I get 2,598,960. Okay, there's a lot of different 5-card hands you can get out of poker. There's no way we'd even want to think about listing them all. Okay, what we're not going to do in this class, and I'm going to be saying this a lot, is we're not going to do all the math behind it. You're welcome to, but it's kind of messy. Okay, you can trust me that I did it right. So that is the denominator. So now if I go back, that's how I got this number, this denominator. And there is a probability of getting a royal flush. Okay, and that's out of the first 5 cards you get. By the way, is that a high probability or low probability? Yeah, that's a really low probability. Okay, so if you really want to understand cards, you want to be able to figure that stuff out. Do you think I ever had to do that? What do you think? Think I ever had to do that kind of the card probability stuff? Okay. I could have put it in my 2 truths and 1 untruth, but I didn't put that one in. So the answer is absolutely. I was an intense card counter when I turned 21 a long time ago. But I stopped because they said if I ever came back, I wouldn't be alive. That was the word. That's the words they used. They were going to kill me. So I decided I don't want to die. So I stopped playing cards. But I played a lot in Vegas and won and never lost. But you know how it is. They don't like when you win. Okay, any questions on this example? All right, so here's the next one. Okay, so suppose that you guess randomly on a 20 question, four answer multiple choice quiz. Okay, so yours won't exactly be like this on your exam, your exam that you're going to be taking, but there's going to be some problems that could be multiple choice. And let's suppose that you guess randomly. There's, A, B, C, or D, and each one you just randomly guess one of those. You do it 20 times. What's the probability of getting all 20 of them right? Do you think it's high or low, by the way? Yeah, this one is extremely low. But what we want to do is we want to kind of figure this out. And this is very different than the card example. With the card example, once I told you this was a king, that changed the probability that this one is a king. On the other hand, if I guess randomly on a 20 question, four answer multiple choice question, and let's say I, randomly guessed that it was the question number one was B. Does that change the probability of getting B for question number two? What do you think? Does that change it? Don't see y'all jumping in. So if I got B for the first question, because I randomly picked B, does that change the probability of getting B for the second question? Don't see y'all jumping in. It doesn't change it at all because each time I'm randomly picking out of four things. So knowing that I got B the first time doesn't change the probability that I'm going to get B the second time because I'm just randomly picking each time. So the probability the first is correct is 1/4 because there's one chance of get one of them that's right, and there's four to choose from. Does that make sense? Okay, now the probability the second is right, given the first, is still going to be just 1/4 because it doesn't change anything. The third is going to be 1/4. The fourth is going to be 1/4. They're all going to be 1/4. And when you have a bunch of probabilities over and over and over again, you just multiply. So that gives me 1/4 times 1/4 times 1/4. And I do that 20 times. And then you may or may not remember, but if you multiply the same number over and over and over again 20 times, that's the same thing as taking that to the 20th power. Because it would take a long time to type that in the calculator if you had to multiply over and over and over again. But to write 1/4 to the 20th power, that's actually quite easy. Okay, any questions on that? And if you do that, here's the number you get. My guess is a lot of you may not know even how to read that number. I think you write 0.000, but how do you even read that? Because 1,000th would be right here if that were a one. This is 1 millionth. This is 1 billionth. This is 1 trillionth. So it's less than 1 trillionth of a probability. Okay, so guessing is probably not a good idea if you want to get them all right. Probably want to study ahead of time. Any questions on this example? Any questions? So a lot of calculation stuff. Okay. So just to let you know, in this case, we were allowed to, if the first one picked and you have to, choose B, then that doesn't change the probability of getting B again. So I can repeat it over and over and over again. It doesn't change anything. Because what's happening is it's not like we're taking a card out of the deck. So in that case, we call it with replacement. So if I asked a different question, I said, all right, what's the probability if I pick a card, I look at it, I put it back in the deck, mix the deck, and then pick another card. What's the probability that both kings? That would be different than what we did before because that would just be 4 out of 52 times 4 out of 52. Because we put the card back in the deck, and that's why we call it with replacement. And probability of A and B is just probability of A times probability of B, but only when it's with replacement for the kind of card example. Any questions on that? If I'm going too fast or you have any questions, please stop me. Okay. All right. So here's the next thing. Okay. Y'all know what this is? What are you looking at? What is that? You've probably seen it. Maybe you don't know. Okay. That's a lottery ticket. Okay. But I'm going to be honest. This is a really old one. Right now, it's I do the statistics, and this is a very bad time to buy a lottery ticket. Whereas a couple weeks ago, a few weeks ago, was a really good time to buy a ticket, and I bought a ticket, but still lost. But at least I had my statistics were better. Okay, and the reason had to do with the amount of money you win if you win the big prize, and that was when I think it was 1.7 or 2.7 billion dollars, something like that. Yeah. Yeah, it was 1.7 billion. It's even more than a billion. And by the way, I bought the lottery ticket and I lost, but hey, I tried. Okay, right now you make much less if you bought a ticket. So what is the probability of winning? Okay. So the first thing is you have to know the rules. This was a Powerball ticket, by the way. And the way it works is you pick five numbers between 1 and 69 and one power number between 1 and 26. So you pick that, and then, on that night or the next night or the night after, then they go and they have balls basically in a big tube and they're numbered 1 through 69. They grab five of those balls. And then they have another tube that has numbers 1 through 26. And they grab one of those balls. Any questions on how the Powerball ticket works? Okay. Now you may not see it, but that's two tickets there, I got two sets of numbers. So now if I want to find out the probability of winning, then it's the following. Okay. So the first thing is how many ways are there of winning? Well, there's two because I've got basically two tickets. So there are two sets of numbers that'll make you win or make me win. Okay. And now, how many ways are there picking five numbers between 1 and 69? Well, then we go back to this guy, and we saw that we're looking between 1 and 69. So instead of 52, this is 69. And we're still picking five numbers in this case. And hit calculate. This is a very big number. Okay, do you know how to read this number? This is 11,238,513. Any questions on that? Okay, so I'm going to take 2 for the numerator, and I'm going to have 11,238,513. And then there's the power number. That is one number that's picked between 1 and 26. And there's 26 ways of doing that, and it's independent, right, from the other five numbers. So it's like with replacement. So it's 2 over 11,238,513 times 26, which is this guy, 0.000000000684. Okay. Do you think I won, by the way? Did I win the lottery? You should be able to guess. Because if you have that small a chance, no, I didn't win. You probably would have read in the news someone in Tahoe won, but I did not win. Okay. There's actually other ways of winning too that you win a lot less money. I've won $4 before, and that's if you get like one right and the Powerball or something like that, or maybe it was two right in the Powerball, something like that. Um, but no, I didn't win. Okay, but it's helpful if you kind of understand that because then from there, if you multiply that by how much money you make, the 1.7 billion, actually that kind of helps you on deciding whether it's a good deal or not. See how that works? And I do a lot of statistics to decide, hey, what's a good deal? And we'll talk about expected value next week, and that's to find out whether it's a good deal or not and how good a deal it is. Any questions on this example here? All right. So here's the next one. Suppose that 20% of all students taking stats at LTCC are African Americans, and 40% of all stats students at LTCC are non-STEM majors. If 22% of LTC stat students, non-STEM majors, are African Americans, and you pick a randomly selected African American taking stats, find the probability that stat student is non-STEM. So what most people find in terms of the really hard part of this chapter is taking a paragraph like this and turning it into equations so that you can plug in and get the numbers out. Okay. And this class is going to be like that a lot. There's going to be a lot of reading, and you're going to have to take that reading and you're going to have to turn it into equations or, plugins or whatever. Okay. I also want to give you a heads up. If I have the word suppose, do you know what that means? This is not a statistics question. Do you know what it means, though? I don't see y'all jumping in. Okay. What it means, I just made these numbers up. So please don't quote me on these numbers because I just made some numbers to make it easy to do. Okay. When I tell you and I cite a source, then you can trust it. Does that make sense? And then it wasn't made up, but these numbers are made up. So I figure I should let you know that this is not necessarily the percent of people that are students taking stats that are African American. I really don't know. I just threw a number in to make it easy. Okay, so when you have a problem like this, what's the first thing you should do after reading it? I just read it. What's the next thing? Any thoughts? This is strategy. Nothing about statistics necessarily, but it's good strategy. So I just read it. What's next? Okay, I don't see y'all jumping in. So let me tell you a big suggestion. Do what I did, read it just like I did. And then the next thing you should do is read it again. But the next time you read it very slowly. And every time you see a number, decide what that number represents and give it a variable. So here we have 20% of all students taking stats are African American. So I'm going to let A be African American. That sounds easy, doesn't it? First letter of African American. And if 20% are African American, then the probability of picking an African American, all right, P, parenthesis, A, and parenthesis, is 20%. And you always want to turn that into a decimal. 20% is 0.2. Any questions on how I came up with this first little piece here? Okay. 40% of all stat students at LTC are non-STEM majors. So I'm going to let N be non-STEM. So I'm going to go P parenthesis NN parenthesis, or the probability of being non-STEM, is 40% or is equal to 0.4. Any questions on reading this one little piece at a time, and every time you see a number, you write down what the symbols are for that number? Okay, so next, if 22% of all LTC student non-STEM majors are African American, all right, so that tells us that of the non-STEM majors, 22% are African American. So if you're given the person is non-STEM, then the probability of being African American is 0.22. The way to do it in symbols is P for probability of African American, and that line means given, and N for non-STEM. And then equals 0.22. Have I lost anyone there? That's usually the hard part. Okay, if you don't turn these into symbols, it's going to be pretty impossible to do this. It's just too many words. Okay, then you read, you pick a randomly selected African American taking stats, find the probability that the student is non-STEM. So now we picked an African American. You want the probability of being non-STEM. So that is P parenthesis non-STEM given African American. And it's what we are asked to do. So I like to write equals question mark because my goal is to answer that question. Any questions on taking this big paragraph and turning it into math symbols? Any questions on that? Have I done anything that is really confusing? Okay, and it takes a lot of practice to get good at this. All right, so once we've done that, now we can just use some formulas. Now, the probability of A and B is the probability of A times the probability of B given A. And by the way, if you switch the letters A and B, that doesn't change. Probability of B and A is the same as probability of A and B because that's just English, right? So if I switch A and B, it still works. So probability of A and B is also probability of B times the probability of A times given B. So probability of B times the probability of A given B. So you can go either direction. And then we just plug it in. So what we can do is if we want to solve for this probability of A given B, I can divide both sides of this bottom one by the probability of B. And I get the probability of A given B is the probability of A and B divided by the probability of B. Do you see how that formula works? Just by dividing both sides by the probability of B from this guy, you get this guy. Any questions on that? Okay. So the probability of A and B is the probability of B times the probability of A given B. I can write that down. Now, the letters don't matter. You can change the letters. It's still correct because this is just general A and B. I can rewrite this as the probability of A and N for N for non-STEM, A for African American, is the probability of N times the probability of A given N. Just everywhere I saw B, I wrote an N. And then I've already figured that out because the probability of being non-STEM was 0.4. That came from up here. The probability of A given N, that was this guy, was 0.22. So that is 0.4 times 0.22. Okay, but that's not what I want. I want the probability of N given A. But again, that's our formula here. So now instead of A and B, I have N and A. So that's the probability of A and N divided by the probability of A. Do you see how the letters got switched? Here B was a second. Here A is a second. So everywhere I saw a B in this formula, I put an A here. Do you see? And N was the first here. Here A is the first. So where I see an A here, I need to put an n. And a and n is the same as n and a. That doesn't matter. And now 0.4 times 0.22 is 0.088. I just put that in a calculator. Or I did in my head, actually. And then probability of A, that was 0.2. We found that one already. That was given. So it's 0.088 divided by 0.2, which is 0.44. And there's my answer. Any questions at all on how I did that? Any questions? Okay, now let's go to the next type. And by the way, this is a key formula. Probability of A given B is the probability of A and B divided by probability of B. And also, you can rewrite it as probability of A and B is probability of A given B times the probability of B. So we had those formulas already. Okay, here's another one. Let's suppose now we have dice. And let's suppose I roll these two dice. Okay, I just rolled them. You can't see it. What is the probability that the two six-sided dice, what's the probability their sum is a 5? Any questions on the question? Okay, so how many ways are there of getting a 5 with two dice? Here's a hint. One way is right there, a 1 and a 4. That would give you a 5, right? What are the other ways of doing it? We have a 1 and a 4. You could get a 2 and a 3. You could get a 3 and a 2. Or you can get a 4 and a 1. So how many different ways are there? There's 4 different ways, because those are the only ways of doing it, right? And then, how many ways of rolling a dice? Well, you think about it, you could have a 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. So if you have the first one's a 1, that gives you 6 things. If the first one's a 2, gives you 6 more. And then 6 more, then 6 more, then 6 more. So there's 6 of these, and for each of these, you have 6 of these. So that gives you 6 times 6, which is 36 ways. So the probability that if you roll two-sided die, that the sum is a 5 will be 4 out of 36. Okay. And by the way, you can always drop in a calculator. You can reduce and make 1/9, put in a calculator, whatever you want. But I like to show you as a fraction because that shows how I did it. Because I thought, hey, there's 4 ways of getting the sum of being a 5, and there's 36 die rolls. 6 times 6. Any questions on that? Okay, now the last piece we're going to do is what's called a contingency table. Okay, so now let's suppose a survey was done asking Lake Tahoe Community College transfer students where they plan on transferring to and what living situation they will be in when they transfer. Kind of a good survey. And here's what they got. So they're going to either transfer to Cal State University or a University of California, UC campus, or a UNR, University of Nevada, Reno, or some other university. Okay. And where are they going to live? They might live in an apartment. They might live with their parents, or maybe in some other situation, right? Maybe there's going to be some transfer dorms, or I don't know, maybe homeless, but they're going to have some other living situation. Okay, so then there's these numbers. So I want to let you know this is called a contingency table. For example, what do you think this number 8 represents? What does that mean, that number 8? Any ideas? What do you think the 8 is all about? When you see that number 8, what does that tell you? Yeah, there are 8 students about what though? In fact, there were 246 students surveyed. Yeah, 8 students will live with their parents. A little more than that. It's 8 students will live with their parents and go to a UC campus. Do you see? Does that make sense? If you wanted the total to live with their parents, you would say 34 plus 8 plus 7 plus 15. 8 of them are going to UC campus of the ones living with that want going to live with their parents. Do you see how that works? Any questions on that? Okay. So we want to find the probability that a randomly selected student will go to a UC campus or live in an apartment. And there were 246 students. If you add up all these numbers, that's what you get. So the key word here is or. We haven't done an or question. Now it's time to do an or question. I know you all know what the word or means, but you may not have thought about it mathematically. So here's the big formula. That's the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. Because the idea is if you just add the probability of A and the probability of B, what you've done is you've added up all the ones that are, say, in our case, going to go to a UC campus, and you've added also the ones living in an apartment. And these 33 were added in 2 different places. Do you see? So that's why you have to subtract the and. And that's how the formula works. So now let's just change the letters. The first was UC campus. The second thing to look at was the apartment. I'll call that A. So UC or A, probability of UC or A is the probability of UC plus the probability of A minus the probability of UC and A. Any questions on that? Okay, so then we go and do it. UC or A, that's going to be the probability of UC. The UC is going to be 33 plus 8 plus 19 divided by 246 because there are 246 students. Probability of A, that's going to be 43 plus 33 plus 19 plus 22 and divided by 246. And then minus the probability of UC and A, that's 33 out of 246. Any questions on how I came about this equation? Okay, I'll let you throw it in a calculator. I don't want to waste your time. I'm assuming you all know how to use a calculator, basic calculator. That's all this is. All right, here comes some important definitions. So the first is 2 events, A and B, are mutually exclusive if the probability of A and B is equal to 0. So kind of mutually exclusive means that they're not going to both happen. Because the probability of A and B is 0, that means A and B won't happen, right? No chance, 0 chance. We call that mutually exclusive. So are transferring to a CSU and living with parents mutually exclusive? So now to find that out, you should always do the calculation. Transferring to a CSU and living with parents. Probability of that, we go over here and we see CSU parents, there are 34 of them. So the probability will be 34 divided by 246, and that's not 0. The only way you're going to get 0 with a fraction is if the numerator is 0. Does that make sense? So if it's not 0, then it's not mutually exclusive. So transferring to a CSU and living with parents are not mutually exclusive events. Any questions on that? Okay. Now the next formula is a little more complicated. And that is 2 events A and B are called independent if any of the 3 are true. The first is the probability of A and B equals the probability of A times the probability of B. The second is the probability of A given B is equal to the probability of A. So if you know B happened, then that doesn't change anything in terms of deciding what the probability of A is. And the third is probability of B given A equals the probability of B. So if you know A happened, that doesn't change the probability that B will happen. Any questions on that? Okay. If one of these is true, they're all true. If one of these is false, they're all false. So all you have to do is test one. And what I recommend is test the easiest. Okay. And notice, by the way, the first one, you're going to have to do three different probabilities. Probability of A and B, probability of A, probability of B. You have to do all three of them to check. The others, you have two. So usually it's going to be one of the others, unless you happen to be given these three here. So a question is, are living in an apartment and transferring to UNR independent? So to find out if they're independent or not, we pick one of these. So we could look at the probability of living in an apartment and, given UNR. So let's go back. So given UNR means we're only going to look at the UNR, the students going to UNR, and we're going to ignore all the rest of the students. Because once we're given UNR, that means just look at those. So when you're given something, that means you're going to isolate to that group. And then we want the probability of living in an apartment given a UNR. So there were 19 of those UNR students living in an apartment. So 19 will be the numerator. And then 19 plus 7 plus 15 will be the denominator. And 19 plus 7 plus 15 is 41. And I popped that in the calculator, and I got 0.46341. Okay, now if you get rid of the given, because that's what this formula tells you, probability of living in an apartment, now we count the apartment, those living in an apartment, 43 plus 33 plus 19 plus 22. And I got 117 when I did that calculation. There's no given, so our denominator is the total, which was 246. And I got 0.4756. Are they equal? What do you think? Are they equal? They're not equal. 0.46341 is not equal to 0.74756. They're not that far from each other, but they're not equal. So if they're not equal, then they are dependent. So hopefully you know in English the opposite of independent is dependent. We'll be using that in this class a few times, actually. Any questions on that? Any questions on how to calculate that? Okay, so if they're not equal, then they're dependent. All right, I want to give you kind of a warning. I like to think of chapter 3 and doing this stuff. I like to think of it as kickboxing. Okay? If you have to be in a ring and kickbox, is that hard or easy? What do you think? Yeah, that's hard. But if you watch a couple other people kickboxing, is that hard or easy to watch? Yeah, that's easy. Okay, chapter 3 is just like that. So I want to give you a big warning, and that is watching me do it is a lot easier than doing it yourself. Okay. And by the way, not only to give you this example, but I know it for a very specific reason because, I teach math, you know that, and statistics, but there is another thing I've taught, and that was martial arts. So I've actually taught kickboxing in a way. And I definitely know. So I've been a kickboxer and I've also watched it. And it's a whole lot easier to watch than to do. And chapter 3 is like that too. It's much easier, especially these word problems, to watch me do this than it is to do it yourself. So the best thing to do is, you watch me do it, you work on it, then you do practice, practice, and more practice. Any questions on that? Okay, so make sure you practice a lot. Don't assume that if you understood what I said, that you'll be able to do it yourself, because it's not the same thing. Doing it yourself is much harder, especially with this chapter. All right, next thing I want to show you. What haven't I shown you yet? No one's saying? The secret word. The secret word for week 2 webinar is given. Because we learned about if you have that little the vertical line segment, we say probability of A given B. So the secret word is given, G-I-V-E-N, is given for the secret word. So again, I try to make relevant secret words that you probably wouldn't just randomly guess. Any questions on the secret word? Okay, I want to mention, since people were asking about it anyway, this is week 2. What's important about the number 2 that you may not be that happy about? Yeah, the number 2 is an even number. Now, because number 2 is an even number, that means you have an exam. So just let you know, the exam must be taken, by Sunday, but I recommend maybe taking it by Friday. That way, if something happens like I couldn't get it, like I couldn't get a LibreText for an hour or so. I couldn't get the textbook or my calculator for an hour. And that would suck if that's the only time you have to take the exam and you can't even get online. So that's why I recommend doing it a little early. You don't have to do it today, but don't do it Sunday night. That's a bad idea because things can go really wrong then. So you have the exam, and the way I create the exam, because I create it, is what I do for this exam is you have chapter assignments. Do you remember that? Right? You went in and you had to do, sometimes you call them homework problems, but with online classes, everything is home. But you had a chapter assignment questions, right? And so what I did, and those are randomly selected. I don't know if you know that. But now with the exam, you're going to have somewhere around 20-ish questions, but some will come from chapter 1, some will come from chapter 2, some will come from chapter 3, and they're going to be randomly selected by the computer. So for example, you're going to have different questions than maybe your best friend in the class. Okay? You're going to have totally different questions. So don't just assume that, hey, if you saw your friend's answers, you can do it. That's not going to help at all. So they're randomly selected, and that's how it's going to work. Okay. There also can be written questions where you have to actually, and those are somewhat randomly selected too, but the numbers aren't random. But there's a whole bunch that it comes out of. And then you have to answer possibly a written question. Yeah. So the non-written are even more than similar to the chapter assignments. I take the chapter assignments and then I have the computer randomly select a few for you to do. Does that make sense? So the best way to get ready for most of the exam is to make sure that you can do the chapter assignments. Okay, so if you got one right, you can still try again and do some more. You can always, even if the assignment's over, you can actually go and do it for practice. It doesn't change your grade on the assignment, but that way you can practice it. Okay. And then one thing to get ready for written problems is to look and redo the possibility, for example, the discussion posts, because those are written also. That make sense? All right, so now what I want to talk about is the project. Okay, and I'm always happy to answer questions, by the way. I always have one eye on the chat box. So let me go to let's go here actually. Okay, here's your syllabus. Okay, which pretty soon is going to go to the modules. I was supposed to do that yesterday, but I forgot to put that in. So it might eventually go to the modules, but you can always click on syllabus and go to syllabus. And you will notice a few things. One is project one is due February 8th. Okay, so that's almost a month from now. Okay, it's 4 weeks minus a day from now, right? So it's due February 8th, but don't wait till February 7th, please. It will go very badly for you. So it's going to be February 8th. And as I mentioned in the orientation, you are required to work with at least one partner. You can have two partners as recommended, so 3 people in a group. And again, if you don't have a partner, go to that discussion board, Project One discussion board, and ask for partners. Okay. So that's a big deal. And notice that Project One is 10% of the grade. All of the chapter assignments combined are 10% of the grade. So the project's worth pretty much. So make sure you do well on it. Okay. So that's the thing. And just let you know, what did I tell you in the webinar? What are you not allowed to use for the project? What are you not allowed to use? Yeah, not allowed to use AI. I will know. And by the way, I don't know if you know, I'm a coder. I think I've told you that. I made some coding in the background that will tell AI to do something that you probably wouldn't do. And I'll be able to tell they're using AI because AI will look at my code and no. And then it'll do something that you wouldn't do. Does that make sense? So do not use AI. Okay, I'll be able to tell. Okay, if you use AI, it's going to be really bad for you. Okay, so don't use AI, use each other, talk to each other and get help from each other. That's for sure. Okay, so you are going to collect quantitative data. Do you remember what the word quantitative data means? This is a disastrous mistake some people make by not using quantitative data, and then it's over for you. Remember what the word quantitative means? It happened last week in the webinar. We talked about it. The word quantitative. And remember? Yeah, it means that the answer to the survey question is a number. So that would be something like, how many, how many miles have you driven in the last month? Yeah, quantitative is not word answers. That'd be qualitative. Quantitative is number answers. Got it? Very important. You do word answers, it's a disaster for the project. Okay, so quantitative data, and you're going to use a computer to display all of the charts discussed in the class. Okay, let me click on this project one because now we can actually go and understand everything it talks about. All right, so think of a quantitative investigation where you ask people a survey question that someone might contract out to have done. Okay? You're going to have to identify that someone who might do it. Okay? Now, officially, you don't actually have to get someone to contract it out, but if you can't even imagine someone contracting it out, then this project will not work. Okay? Just to let you know, you identify who that someone is, and the writing of the project is to that person. Does that make sense? Okay, and that someone, for example, could be Governor Newsom. Okay, and it doesn't mean you really have to call Governor Newsom. You could pretend that Governor Newsom would contract it out. Does that make sense? And you would write that in your project. Okay, and then throughout the entire project, you can talk about what Governor Newsom needs to hear. Okay, now you're not going to probably choose Governor Newsom. It's going to be someone else. But you're going to have somebody that you're going to pretend is contracting you to do it. Then you're going to go and perform this investigation and produce a report on it as though you were handing the report to the person paying for the services. Okay? Whether it's the governor or whether it's a, manager at Safeway supermarket or, whoever it might be. Does that make sense? Okay. The whole purpose of the report is to make recommendations based on the finding. The recommendations need to be throughout the entire paper. Okay? Throughout your whole, I use the word paper, but you're not going to use paper, but you're going to use computer. But still, throughout the entire project of the write-up, you're going to make recommendations. Does that make sense? Okay. You have to include a description of the sampling technique that was made and how the technique was applied. Here's your choices. You can use simple random sampling, but I'll let you know, nobody uses simple random sampling because that's almost always impossible. So if you even use the word random, good luck. You're probably going to lose a lot of points because there's no way you can do it randomly. Okay? But you could stratify sampling. That is a very common way of doing it, and that's something you can do. Or you can use cluster sampling. And I have links if you forgot what those were, and it reminds you what those two kind of techniques are. So I strongly recommend one of those two and do it that way. Okay. Discuss any bias that might have occurred due to your sampling technique. Okay. And bias represents misrepresented of the population so that the sample data will not represent the population data. So in other words, the sample mean might be larger than the population mean because of your bias, or might be smaller because of your bias. So that's something you need to talk about. If you don't think it would be larger or smaller, then it's not even bias. Does that make sense? Any questions on that? Okay. So just a big note, the sample size must be greater than 30. By the way, is the number 30 greater than 30? No. I don't know why, but I get a lot of projects that they sample 30 people. And they lose a lot of points because that's not greater than 30. One thing I'm going to tell you is that you're not going to know why I'm requiring this until pretty much after the project is due. Because then you're gonna learn about the big number 30 and how important that number is and being bigger than 30. So, but we're not there yet. Right now, you just got to trust me that you need greater than 30. Otherwise, you have kind of a worthless project. Okay? So you'll lose points if you don't have greater than 30. Okay? As I mentioned, don't use the word random because good luck. Okay? You must include all relevant charts. So the charts you have to include are histogram, stem and leaf, and box and whiskers. Okay, those three have to be there. And just to note, if you have a stem and leaf plot, so what would be the problem if your survey question was something like, how many countries in Africa have you been to? That's quantitative, right? That's a number. What's the problem with that? Why would that not be a good survey question for this project? Any ideas? Okay, so and let's say your population was California community college students. Yeah, you should identify the population, by the way. Okay, the reason why that wouldn't work is probably, let's say you asked 31 people, probably all 31 of them would say numbers between 0 and 3 or something. Does that make sense? I'd say 0. I've never been to Africa. And a stem and leaf plot doesn't work if all the numbers are single digit. So you do want to make sure that your survey question is going to have at least some double digit or higher answers. Does that make sense? So don't ask on a scale of 1 to 5 or 1 to 10 because that's single digit also. Do you see how that works? Don't say, how many times in the last week did you go out to a restaurant? Instead, you might say, how many times in the last year did you go out to a restaurant? Because that'll have double digits. Do you see how that works? So that's to make sure the stem and leaf works. Okay. If you want, and if it's relevant, you can do pi and line. Okay. But these three, histogram, stem, and box, those are the most important, and they have to be there. Okay. You must use the spreadsheet program and not a calculator for the statistics. Okay. And the three main charts, which I'll show you in a bit. Okay. So maybe I'll show you that now, actually. Let me just do this and this. Okay, remember the spreadsheet program? Let me go to OneVerstats. So I showed it to you, but now we're going to actually see it. So the first thing you're going to have to do, and I showed you this in the orientation, is you're going to go to File, you're going to go make a copy, going to give it a name, you're going to make a copy. I don't need to make a copy for myself, but you should make a copy. And then you're going to share it with your partners so that you're all using the same copy. Then what you're going to do is you're going to highlight these numbers and you hit the backspace to empty those out. Then what you're going to do is you're going to enter your data. Okay? So let's say your data values, you did your survey and one person said 45, I hit enter. The next person said 33, the next person said 76, the next person said 28, and then I'll just 46. I don't want to waste your time, but let's suppose I had 31 of them. You could have 38 of them if you want. Don't do 1,000. That would take too much typing and too much work to ask that many people. 55, 21, 37, 55, 22, 37, 41, 37, etc. Okay, so you'll notice a few things. One nice thing about this is you don't even have to go to anything. You just type in the data and it'll give you the minimum, the mean, the sample variance, sample standard deviation. The variance, that one's don't even use in the project. We haven't talked about the variance. Sample standard deviation, median, maximum, Q3, N for sample size, Q1. Okay, those are the biggies. The stuff, confidence level, don't put that in your project. We haven't done it yet. You're not even supposed to know what that means yet. That'll come later in the course, but not yet. Same thing with this H1 stuff. Don't put that in, any of this stuff. None of this goes. Okay. The only other thing could be the Z-score. And I made it so if you put in a value like 22, then it'll give you the Z-score for that number. Okay. Don't just use whatever you saw that you copied in. Make sure you use one that's relevant. So one thing you probably want to use is the minimum is 21. So if I put in 21, then the Z-score is negative 1.3333. So is 21 an outlier? Okay, 21 is not an outlier because an outlier has to be either bigger than 2 or smaller than negative 2. And negative 1.33 is not bigger than 2 and it's not smaller than negative 2. So there are no outliers on the small side. For the maximum in this case, the maximum is 76. So now if I put in 76, and my Z-score is 2.3333, is 76 an outlier? Yes, 76 is an outlier because that number is bigger than 2. Do you see? And by the way, if you want to find out if there are any more outliers, there can't be low ones. You go to the next highest, which is like 55. And if I put in 55, then that gives you 0.9333. That's not an outlier because that's less than 2. So that meant that 76 is the only outlier. So then you think about, well, how would the client react to that? And what decisions will the client make based on the fact there was an outlier at 76 and no other outliers? Okay. And it would depend what the survey question was and what the client's needs are. Any questions on that? Okay. This will also give a histogram. This will also give a stem and leaf. So this is how you get there. You go to stats. You go to stem and leaf. And there it is. Okay. By the way, all this wording stuff, I put that in. So if I have a blind student, then they can that they don't have to be able to read a chart because this won't mean anything to a blind student. They can't see it. The screen reader would read this to them. But basically, it's this part that you need. So that's the stem and leaf. Do you see? And then you talk about what does the stem and leaf show you and what decisions might the client make based on it. Notice that from the stem and leaf, you can see that we have a mode of 37 because we have and there's 3 sevens there. So what decisions might the client make for that? Okay. You can also go to stats. And by the way, this is for 2-digit numbers. If you had 3-digit numbers, see this S and L left 10 caret question mark? Make that a 2 for 3-digit numbers. Okay. Most people have 2 digits, and that's what you do. Okay. If I go to stats, if I go to box plot, should give it to me. Uh-oh. Let's try it again. Stats, box plot. There it is. For some reason, it was slow. Okay, there we go. And there's the box plot. Remember, as soon as you call it box and whiskers, same thing. This gives you that 5-point summary. And I want to mention that the box is the most important thing. That is the middle 50%. Middle 50% in this case is between 33 and 46. So how might the client react to the fact that 50% of the sample answered between 33 and 46? And it'll depend what your survey question and who your client is and what the needs are. Do you see how that works? Okay. And notice this histogram, you can see it's unimodal, has one high bar. Okay. You can see this kind of little extra over here. So it's somewhat skewed right. And if it's skewed right, you can't use the empirical rule. You have to use Chebyshev's. And then you do that. Any questions on this so far? Okay, then one more thing you have to do for the project. And that is the key columns here are this column C and column D. Do you see? So you're going to copy those 2 columns. And by the way, if you don't know, that's Control C. We'll copy Max. Probably are different, but I don't know Max well. And then you're going to paste it right onto your project. And that is an absolute requirement to paste in those columns. You also have to paste the box plot. And again, if you right click, you can copy the image and paste it in. Okay, and you should copy and paste the histogram, and you should copy and paste the stem and leaf plot. Copy and paste those into your project. They must be directly in your project. Got it? It's not hard to do, but you have to remember to do it. And a lot of people forget. And I take a lot of points off if you forget. Any questions on that? Okay, let me go back to where were we? There. The project. So that was the spreadsheet that we have. Okay. So you must interpret all the charts. Again, talk about what the client is going to do, what decisions the client will make. Okay. Okay. What does it say about the population? What does it not say about the population? Compare and contrast the charts. Okay. Okay. And I'm going to let you read through all this, so I'm giving you some of the important things. Okay. You should give a list of summary statistics that are important. And we saw that. Okay. You should interpret each, and then not just interpret them, but you should talk about what decisions the client will make based on each of them. Okay. One at a time. So the decisions the client makes should be all over the place. Okay. All right. You must pay special attention to the standard deviation. Okay. That is one of the main pieces of this project. You have to have a full paragraph on it. Okay. Explain the decisions the client will make based on it, what it tells you, how does it affect the empirical rule or Chebyshev's, whichever is relevant. How about z-scores? That's all about standard deviation also. Okay. So is that clear? Do not just state definitions as a definition. because that's worthless. It's how is the client going to use this material and what decisions will the client make? Okay. And I want to let you know this is this is like a paper. So there should be an introduction, a body, and conclusion. That's a standard paper. So at the end, there should be a synopsis of the importance of your finding. That's kind of the conclusion. Okay. And then, all the important things. And then also what you might do to do further studies that might help your client understand it even more and learn more about what's going on. And that could be additional survey questions. It definitely is going to be how would you reduce bias with a better sampling technique? Doesn't mean you have to do it, but you have to talk about how you could. And if you say there was no bias, you're wrong. It's impossible, pretty much impossible to do a survey of people and not have any bias. So make sure you talk about that and how that bias could be reduced, not zeroed out, but at least less than what you had. Okay. All right. Another big thing which I mentioned in the orientation, who are you not allowed to survey? Do you remember? Children. Do not even think about surveying children. Okay, you're not allowed to survey children. So do not go to a high school and survey the high school kids. Do not go to an elementary school. Do not do that. I'm going to tell you a few more things, and this is more for you. But if you're let's say you worked in a restaurant and you wanted to find out, I don't know, how much your customers are spending. And make sure that you get your boss's permission before you go and do the survey. Does that make sense? Because I don't want anyone getting fired because of this project. Okay. And similarly, if you want to go into, some kind of supermarket or something, make sure you ask the manager if it's okay. Okay. And just a note, to get people to answer your survey, one of the best things you can do is before you ask the survey question, you say, I just want to let you know I'm taking a statistics class and I have to do this project, which makes me survey people. Can you answer my survey question? And they'll just about always say yes if you start with that. Okay, so if you tell them you're a student and it's for it's for this hard project you have to do in your statistics class, they're going to feel pity for you and they're going to answer your question and then ask the question. Does that make sense? Okay. Also, make sure you identify what your population is. It could be all community college students, could be all people in California. It probably won't be all people on Earth. Could be, but it probably wouldn't be. Okay. But make sure you identify your population. Okay. But it shouldn't be all people. It could be all adults on Earth, for example. But identify who is your population. Like I said, if it was at the restaurant, it would be, all people who walk into the restaurant and buy food, get, so all customers. So it could be that. So there's lots of different, populations it could be. Make sure you identify it. Any questions on that? I do have, and I'll let you click on that. I have examples of feedback I've given. And I want to remind you about timeline. So the first thing, as I mentioned, is let's go back to the syllabus. The project is due on February 8th. Okay. So when you go to here, it says, I'll be happy to look at a rough draft of your project if you can bring it to me by Thursday at 8 a.m. Okay, the week before it's due. So it's due on the 8th. Thursday, by the way, is the 5th, because that's 3 days before it's due. Do you see? But don't wait until Thursday. I mentioned this in the webinar, in the orientation webinar. I recommend like a Monday or Tuesday before, because that way you have more time. And I read it on a first email to me, first read basis. Okay, or first looked at basis. So that's how I'll do it. And then I'll give you lots of feedback, usually like a 10 or so comments on how to improve it. And that way you can fix most of the things that you're going to lose points on. So definitely, do that so I can help you. So again, so if you want to have a draft mostly written by like a week before it's due, a week before that February 8th would be February 1st. So try and have your timeline so that you can try and have your draft, around February 1st or 2nd or 3rd. But not February 7th because then I won't read your draft. I only read one draft, by the way. Don't resend it a second time because I've had people do it all day long. So only one draft is read. I'm sure Peter will read it too, right, Peter? If you asked him for help, the tutor. Okay, so definitely you can ask the tutors to get help also. Okay, then maybe a week before then, so that would be like, maybe a couple weeks from now, you're going to want to have your data collected because it might take some days to do the writing. Does that make sense? Okay, and then this week sometime, kind of maybe by Sunday, be working with your partners and decide what what you want your project to be. What do you want the survey question to be? And who your client is, what your population is, and how are you going to conduct your survey? What is your survey technique? Will it be stratified? And if it is, what will your strata be? Will it be cluster? If it is, what will your clusters be? And then go to the Project One discussion board and post your idea. After you post your idea, it might take me some hours. I'll reply on whether it works and also suggestions I have for small changes, or maybe no, that won't work at all. Try something different. And that way you won't have a project that doesn't work. Does that make sense? So that's kind of the timeline. Any questions on the timeline or anything about the project? Okay, I don't see questions, and I want to let you know that my goal is always around 7:30 to finish this webinar. Okay, and I'm looking at 7:29, so it's probably a good time to be done. And I'll always answer questions after we stop the recording too. So I'm going to stop the recording, but thanks for coming. And don't forget about the exam. Don't wait till the last minute this week. And also this week, you should be working with your partners and kind of post on the Project One discussion board what your idea was, and I'll look at it and let you know, and I'll reply. And you can look at other people's and what I replied and find out what doesn't work and what does work. That helps too. So I'm going to stop the recording.